Hello, good morning, everyone. So welcome to today's ECA Learning Zone webinar. Today we have James Hunter-Johnson, who's delivering a webinar on emergency lighting and testing solutions. This session is being recorded and will be available to revisit on ECA's website. And this session is CPD accredited. So to get your certificate, please complete the form that I will drop into the chat box at the end of the session, and you'll receive your CPD certificate from NVC Lighting after the session. So just please confirm that you're happy for your details to be passed on to NVC. James will be taking questions throughout the session. So just put your questions into the Q&A box or the chat box throughout, and he's happy for me to interrupt him and put them to him. So thank you very much, James, and I will hand over to you.
That's great. Thank you very much. Now, I hope you can all hear me clearly, and I'm just going to go into slideshow, to text, and okay, good morning to everyone. I hope you can all see that clearly. Kat, does that look right to you?
Looks perfect, yes.
Splendid. Thank you very much. Okay, good morning. Nice to have you all here. As Kat introduced me, my name is James Hunter-Johnston. I'm from NVC Lighting, and we're here for a seminar on the subject of emergency lighting testing. But before I get going, just a few little housekeeping points. First of all, this seminar, including questions, should last for about 1 hour. If it overruns a little bit, I apologize, but that's probably because you've asked some interesting questions. Thank you in advance for that. As Kat said, this is a certified CPD seminar, so your attendance certificates will come from NVC in a few days once Kat has collated all the names and contact details and got them across to us at NVC. We'll then make out your personalized certificates and we will distribute them to you. Hope that'll be okay for you. So that's really the housekeeping out of the way. Here's our agenda for this morning. So we're going to be looking at what is emergency lighting and why does it have to be tested? That's the first part. And then we'll be looking at the different types of testing that are available for emergency lighting. So we'll be taking a closer look at manual test, self-test, wireless addressable test, and wired DALI addressable test. And as Kat said, if you've got questions, of course, you can save them up for the end if you really want to, but it's actually much more useful, I think, for everybody is if you've got a question or something I have said is perhaps not really very clear, if you type it into your chat box, Kat will intercept that, she'll interrupt me, put the question to me, and I'll do my best to answer it as we go along. If there's any question that you ask that I really can't answer as we go along, then please forgive me for my ignorance. I will answer it in writing, having given it a little bit of thought and research afterwards. I hope that'll be okay. At the end of this seminar, you will know, or you will know if you've been paying attention, that emergency lighting has to be tested, and you'll understand the legal and the practical reasons for that. You'll know what the different types of testing are, and you'll know a little bit about the advantages and the drawbacks of all the different types of testing that are available. So that's what you'll know at the end of the seminar. But first of all, I'm allowed one quick sort of commercial slide, just to say a little bit about NVC and who we are. So NVC Lighting, if you've not already heard of us, we're part of a large international group which is focused entirely on lighting. Ultimately, our headquarters is in Hong Kong. We're listed on the Hong Kong Stock Exchange, but you will find NVC and our distributors pretty much all the way around the world. In the UK, our headquarters is in Birmingham in the West Midlands. And from that headquarters, we also run our subsidiary companies in Denmark and Sweden and Finland, etc. So we run the Scandinavian countries from there. Speaking specifically about NVC in the UK, first of all, we are members of what is called ICEL. ICEL is the Industry Committee on Emergency Lighting. And Peter Adams, our technical manager, is on the ICEL Council. He's also on the ICEL Technical Committee. What this basically means is that when it comes to emergency lighting, we're qualified to talk on this subject. We're involved in the process. Whenever the regulations change with regard to emergency lighting, we're in there, we're part of ICEL, helping to refine and define what the regulations should be with regard to emergency lighting. We're also associates of the Electrical Contractors Association. We're members of the Electrical Distributors Association, the Lighting Industry Association, etc. All of this really means that we are connected to and plugged in with, and we're part of the electrical and lighting industry within the UK. And we'd like to be part of these organisations so that we know what's going on in the industry and we keep up to date with current developments. So that's really all I'm intending to say about NVC Lighting Limited. Now we can get into the meat of the seminar and the first part of the agenda. And I'm going to start off just by, if you like, setting out the framework, the boundaries of what I'm going to talk about. And to do that, I'd just like to point out that there are three basic types of emergency lighting. First of all, there's what we call emergency escape lighting. This is lighting which is designed to help people get out of a building safely in the event of an emergency. And that accounts probably for 90% of all the emergency lighting in the UK. It's classified as emergency escape lighting. There's a second type of emergency lighting, which is called emergency safety lighting, sometimes described as stay put lighting. And stay put lighting is actually there to enable people to stay in the building, at least for a short time, when there's an emergency. For example, disabled people. The lighting, the stay put lighting, is there to enable them to get to a place of safety within the building, a refuge area, and wait there until somebody can come and rescue them. That's stay put lighting. And then thirdly, there's what's called standby lighting. And this is emergency lighting, which is present to enable a critical operation to continue until a safe time has been reached when that operation can be stopped. For example, think of a surgeon in a hospital. He's got somebody on the operating table, the fire alarm goes, everyone's evacuating the building. You can't leave the patient on the operating table. There needs to be lighting there that enables the surgeon to take the operation to a safe point before he and the patient can leave the theatre. So that's standby lighting. Those are the three different types of emergency lighting. Now, what I'm talking about today is only emergency escape lighting and emergency safety lighting. I'm not going to be talking about standby lighting at all. It's a specialist subject. Moving on then. So what is emergency lighting? It's lighting that's provided for use when the normal lighting supply fails. That's the technical description of what it is. And there are two ways of providing it. First of all, there's self-contained emergency lighting, and there's a picture on your screen there of an IP65 bulkhead. We call that a self-contained emergency light fitting because it contains its own batteries. So if there's a power failure, it is self-contained in the sense that the batteries provide the power that enables it to continue to run. But that's not the only way of providing emergency lighting. The other way of doing it is with what is called a central battery system. These are not so common in the UK, except perhaps in a few very large buildings. But typically in a central battery system, you'd have a large cabinet, even a small room, full of batteries, usually located in the basement. They're connected to the emergency light fittings with fire-resistant cable, and in the event of a power failure, the battery kicks in and it supplies the emergency light fittings with the necessary power. This seminar is only about self-contained emergency lighting. We're not going to be talking about central battery systems at all and how they are to be tested. Okay, so we're just talking about self-contained emergency escape and safety lighting. That's sort of setting out my agenda, limiting my subject matter a little bit. So why does emergency lighting have to be tested? I mean, this is the subject of the seminar. It's emergency lighting testing specifically. Why does it have to be tested at all? Well, the number one reason is because the law says so. And the law in question is this one. It's the Regulatory Reform Order of 2005. Now, it's pages and pages long. You don't have to read all of it. There are three things, I think, that you need to pick out of the Regulatory Reform Order. The first thing is that emergency lighting is compulsory in most buildings to which the public has access and/or which are places of work. So that means a huge percentage of buildings in the UK must have emergency lighting. It's the law. Secondly, with respect to that emergency lighting system, a responsible person must be identified. The law says so. And thirdly, the law says that that responsible person must put in place, quote, a suitable system of maintenance. And if the responsible person fails to put in place a suitable system of maintenance, then they will be prosecuted under the RRO. And the RRO is the basis of the prosecution. That's the quickest, most direct legal route for getting a conviction. So that's why emergency lighting has to be tested. It's because the law says so. Now, the law says that there's got to be a suitable system of maintenance in place. That begs the question, what is a suitable system of maintenance? Fortunately, good old British standards come to our rescue, and BS 5266 defines what is a suitable system of maintenance. Again, it's pages and pages long. But here are three things you need to know out of BS 5266. First of all, BS 5266 says that with respect to the emergency lighting, you've got to do a monthly functional test of every emergency fitting. That just means switch it on, switch it off again. That's a functional test. Then you've got to do an annual full discharge test. Switch it on for 3 hours and leave it and check that it's still working at the end of the 3-hour period. And thirdly, the responsible person has to put in place a system of record keeping. What that means is you've got to record the fact that the light fittings have been tested and when. You've got to record what the test result was. You've got to record if there were any faults, what their nature was, and you've got to record what you did about the faults. So there's a lot of record keeping involved in BS 5266 compliance. Now, so there's the responsible person, and he's got the law dangling over his head or her head. So there's a considerable amount of risk involved here. And the first risk that the responsible person is facing is the risk that testing just isn't done. And then, unfortunately, many cases where testing is not completed and the records are simply not being kept. Now, it doesn't matter if there's never a fire, there's never an emergency, and nobody was ever killed or injured. If that testing and record keeping isn't being done, the responsible person has breached the law, so they are legally exposed to prosecution. Secondly, of course, if the testing's not done properly, the system might not be working, and therefore there's a risk of death and injury to people occupying the building. And if that happens, there's a further risk of legal action and financial cost, which will come back to the responsible person. And every year there are prosecutions, usually fines are issued, and they are often running into the tens of thousands, even hundreds of thousands of pounds of fines for single incidents in a building. So this is a pretty serious matter for the responsible person. But if you put a suitable testing regime in place, all of those risks are mitigated. So that's why emergency lighting testing is so important. So we're now going to look at what is emergency lighting physically. I mean, what does it actually look like? How does it work? And then we're going to take a quick look at the simplest form of testing, which is manual testing. So here we go. What we've got here on the screen then is a picture of a standard luminaire, something with which I'm sure you're all very familiar. It's a 600 by 600 LED panel, as you'd see in offices all over the country. Attached to that is the LED driver. No light fitting can work nowadays without a driver. And to the left-hand side, that little black box, that is just it's just the connection block. It's not doing anything functional. It's just where you connect the wires. So that's a standard luminaire. A connector, a driver, and an LED panel. Now that is the emergency version of the same thing. And I'm just going to try and move something off my screen. Get it out. Go. That's the emergency version of the same thing. See, we've got a panel and we've got a driver, but now we have an emergency module. And inside that emergency module, there is a set of batteries, usually lithium batteries nowadays. Connected to the emergency module, there's an indicator LED, which tells you what's going on in the emergency module. Is everything okay, or do we have a fault? And outside of all of that, not actually part of the light fitting, outside of all of that, there's usually a key switch. And the function of the key switch is to isolate the unswitched supply for the purposes of the monthly and the annual testing. So that's what an emergency light fitting looks like in its simplest form. I'm trying to move to the next screen and it's not allowing me to do that. We have a glitch. Right, that's better. Can everyone see that clearly still? Shout out to Kat if you
all
can't.
good.
All good. Thank you very much. Okay, so to make it a little bit easier for me to explain and for you to see as we go along, I have turned those photographs into a schematic diagram. So that is a schematic diagram of our LED panel with the power on. So the LED panel is connected to the driver and there's a switched live supply coming into the driver. The fitting is on. If the fitting is to be switched off, the switch opens and the luminaire switches off. So it's on and it's off. Here is the same fitting now in its emergency mode. So we've got the emergency module there sitting in the middle of the screen. There's an unswitched live supply, which is permanently connected to the charging circuit, and that makes sure that the batteries are always 100% charged. There's the key switch outside of the light fitting, and its purpose is to enable a power cut to be simulated for testing purposes. There's the LED driver still in the circuit and connected to the luminaire via the module, but because this is normal running, the power is running from mains to the driver, to the luminaire, and the battery at the moment is out of circuit. During a test, the unswitched live supply would be cut, and then what we see happening is that the battery is brought into circuit, the LED driver is taken out of circuit, and the indicator light switches off to show that there's a test in process, but the luminaire is continuing to run. So that's what's actually happening when you conduct a manual test. You open the key switch, the unswitched live supply is isolated, and the batteries then power the luminaire. That's what's actually going on. So what actually has to be tested and why? Well, first of all, the emergency module is being tested to make sure that it actually does take the driver out of circuit and that it brings the batteries into circuit. And there's a relay inside the module in order to do that. We've got to test that that's all working properly. Secondly, we're testing the batteries to make sure that the batteries are being charged and that they do last the full 3 hours. And thirdly, the test is there to make sure that the indicator light is doing what it's supposed to be doing, that it indicates green when everything's okay, and it switches off when there's a test in progress. So that's what is being tested, and that's why it's being tested. So quick summary then. So manual testing, you're doing it with a key switch. Monthly, that key switch is actuated. You'll do a visual check to check that the luminaire switches on under battery power. You'll keep a record and you'll log any faults that you find, and you'll do that logging manually. And then annually, you'll do the same thing, but you'll leave the key switch disconnected for 3 hours to make sure that the fitting is still working correctly at the end of 3 hours. Now, at this point, if we're doing this face to face, I usually say to people, okay, so what are the pros and cons of manual testing? This is difficult to do interactively, I think, if we're operating as we are over Teams. So I'm going to sort of fill in your role for you, I think, as we go along.
James, sorry, just one question I'm going to put to you.
Go ahead.
Is this the same process under central battery?
Okay. Well, if you remember at the beginning, I said very carefully that this seminar is not covering central battery. So the real answer to that question, Kat, is I don't know. I suspect it probably is. But I'm not an expert in central battery systems. They're a little bit rare in the UK, not unheard of, but I do not know the answer to that question. But I tell you what I'll do, Kat. I will go away and I will research that question. If you could take a note of it, I'll go away and research it. A little bit outside my remit, but hey, it'll be interesting. I'll go and research that question and I will write you a short summary and I'll send it to you in the next couple of days, Kat. How about that?
Thank you, Martin. We'll get that back to you. And another question, is installing a key switch for M-lights a legal requirement?
No, it's not a legal requirement because there are other ways that potentially you could go about manually testing an emergency light fitting. But a key switch is by far the most convenient way to do it. The other way to do it would be to isolate your unswitched live supply back at the distribution board. But I think you'd appreciate that that's a pretty cumbersome and inconvenient way of doing it. So the answer to the question is no, it's not a legal requirement, but it's highly recommended and it's the most practical way of doing it if you're committed to a manual test regime.
Lovely, thank you. I've got a response saying perfect, thanks. Right.
Jolly good. Okay, so what are the pros? No more questions for now?
No more for now.
Okay, so what are the pros and cons of manual testing? Okay, well, they are considerable. Here's some risks or drawbacks, if you like. If you're doing your testing manually, probably the biggest single risk is that the person who does the testing goes on holiday. Christmas, New Year, summer holidays, kids, half term. The tests are supposed to be done every single month. And I would think there are many, many buildings in the country where for at least 1, if not 2 months of the year, the tests are missed or skipped. That means that the responsible person is already in breach of the law. So that's a substantial risk straight away. Secondly, the records have got to be properly maintained. In a really small building, that's not difficult. But the bigger the building, the more difficult it gets to keep the records accurately. And when we say keep a record, it doesn't just mean I did an emergency test on Friday last week. You've got to keep that record for every individual light fitting. So there's a really big risk that those records are not being properly maintained. Thirdly, here's another big risk. You're doing the annual 3-hour test, and you've got a fitting at the far end of a distant corridor in the basement. Are you really going to check that at the beginning and at the end of the 3-hour test? I think there's probably an awful lot of corner cutting in those 3 hours, either of fittings not getting checked at all, or of somebody getting to the end of 2.5 hours and they're hungry and they want to go home and it's time for lunch and what the hell? It just gets signed off anyway. And finally, how do you check a fitting when it's in the girls' changing rooms, or it's an old people's home and it's in the old lady's bathroom, or it's in a data center and you don't have security access? Some places are difficult to physically access, and if you can't physically access it, then the testing isn't being done properly. So there really are some very considerable risks and drawbacks to the manual testing process. Of course, the advantage is that in terms of the acquisition cost of the light fitting, it's the lowest cost there is. This is the cheap solution. The installation might not be the cheapest because you've got to install those key switches, unless you're going to go back to your distribution board to isolate the supply, which is very cumbersome. So the installation cost might be higher because of the installation of the key switches, but actually acquiring the fittings is relatively low cost. But of course, the ongoing cost of manual testing every single month, employing somebody to go and do this testing, that cost is considerable. So short term, there's a low acquisition cost, but over the long term, as the months go by, manual testing is a very expensive way of doing things. So generally speaking, we really only recommend manual test for very, very small projects. It's not what we should be doing in the 21st century on medium and large sized projects.
James, I'm just going to interrupt you with another question.
Go ahead.
Is the site logbook acceptable for the record to be kept on, or does this need to be kept in an electrical format?
It does not need to be kept in an electrical format. In fact, it's commonplace. We do this with all our emergency fittings. We actually issue with them a physical piece of paper on which you can start to keep your record. So yeah, it certainly can be a manual paper-based record.
Lovely, thank you. Yes, they're just saying they do issue a test certification as well.
Yes, some people would do that. That issue a test certificate. But if you're doing that every single month, that is just another cost that just keeps piling up. Manual test is an expensive way of going about things for whoever's paying for it, landlord or tenant. Manual test is expensive because of the ongoing monthly costs that just rack up and rack up. Anyway, we better keep moving on. We've looked at manual test. What I'd like to do now is look at the second testing method that's on our agenda, and that is something which is called self-test. And this is what self-test looks like. So this is a self-test emergency module, and it really looks very, very much like a manual test emergency module. And that is it in normal running mode. So the luminaire is being powered via the driver on mains power. The unswitched live supply is connected. The charging circuit is working. The batteries are being kept topped up. And the LED indicator light is green, indicating that everything's okay. Now, when we go into test mode, this is what's going to happen. The unswitched live supply is disconnected, but rather than it being disconnected by a key switch, which is outside the light fitting, it's now being disconnected by a relay, which is inside the emergency module. So during test, that relay opens to simulate a power failure, and you'll see what's happening there. Whoops. Is that the LED driver is taken out of circuit, the batteries come into circuit, and the luminaire is being powered from the batteries, and the little indicator light goes off to indicate there's a test in process. That is what is called self-test. But it does exactly the same thing as manual test. So monthly, the fitting will isolate itself, it checks itself, and it emits a visible or audible warning if something is not right, something is not working. You'd still need to do a walk around check to check on the status of the indicator. You'd still need to keep your records manually and log any faults manually. And annually, again, after 11 standard momentary tests, the fitting will do a 3-hour test. And again, issue an audible or visual warning if something's not right, and you would have to maintain the records manually. But that is self-test. So no key switch outside the fitting. There's a relay actuated automatically inside the emergency module. That's self-test, very short and simple. Pros and cons of self-test. If you've got a pros and con you want, pro or con you want to air, then put it into your chat box. Otherwise, I'll fill in the blanks for you. Here we go. If you're using a self-test system, you've still got to go and visually check the status of the fitting after the test. So we've still got that risk that fittings in far corners at the far end of the corridor, down in the basement, those fittings can still be overlooked. And you've still got the quite onerous issue of maintaining all the records. And that can easily get overlooked or just not done comprehensively. But it does have some advantages. First of all, a self-test system is relatively low cost to install because you don't need any key switches. The functionality of the key switch is now embedded in the emergency module. Secondly, it is a 100% reliable test solution. It will always do the tests at monthly intervals and the full discharge test every year. So you've removed one of the risks of manual testing. One of the risks of manual testing is that somebody goes away on holiday and the testing isn't done. Well, self-test always does the testing. Doesn't matter if everyone's away on holiday, the testing will be done. And because it's automating that process, it means that it's got a very low running cost and a really very quick payback. Typically, obviously, there's a cost difference between a manual system and a self-test system. A self-test system is a little bit more expensive. But when you take into account the savings in not having to do the manual testing, then we're typically looking at a payback in less than 1 year. So it's a very rapid payback. But here's one of the cons of the self-test system. One of the drawbacks is you've got no control over when the testing is actually going to happen. It's going to happen according to essentially an automatic algorithm, which is embedded inside the emergency module. So it will initiate the test at monthly intervals when it thinks it's appropriate to do so. Now, in an office, that's absolutely fine. In a shop, that might be absolutely fine. But you really don't want your emergency light fitting switching on at 2 o'clock in the morning in a hospital ward where actually all the patients are meant to be asleep and trying to recover from their operation. You don't really want the emergency lighting switching on at 11:05 in the middle of a double maths period in a school when the teacher's trying to get the kids to concentrate on what's on the screen. So not having control of the test schedule can be a bit of a drawback for a self-test system in some situations. In other situations, it's a great solution, but it's not suitable for absolutely everybody.
Sorry, James, I'm going to ask you another question.
Yeah, go ahead. Love them.
Is it a legal requirement to have a drawing showing the emergency light locations in commercial and public buildings?
Sorry, is it a legal requirement to have what?
A drawing showing the emergency light locations.
Yes, I think it is. No, I'm going to qualify that. No, I don't think it is, because you've got different types of emergency light fittings. You've got emergency light fittings on escape routes. You've got emergency light fittings on exits. And you've got emergency light fittings in open areas. Now, I think it's a legal requirement to have a drawing of the location of all of those on the escape routes and the exits. But I don't think it's a legal requirement to have a drawing identifying all of those in the open areas. But you know, Kat, that's one of those really good questions. I'm going to be more comfortable if I check that and write to you about that afterwards. Do you mind if I do that?
Yep, no problem.
Fantastic. I'll just I'm going to double check that with our technical manager at the on the ICEL technical committee. Luckily, I have access to him every single day. I'm going to check that. Okay, so just wrapping up then on self-test. So it's a great solution, very quick payback, and it's good for many small and medium-sized projects, but you wouldn't want to use it where it's important that you have control over the test scheduling. So it's maybe not ideal for classrooms, hospital wards, and a few places like that, where you really do want to have control of the test schedule. Okay, but when we look at medium and larger sized buildings, there really are some challenges which we need to think about as we look at emergency testing. We've talked a little bit about scheduling. I mean, you really do need to have control of the test scheduling in hospitals and schools. We've mentioned those. Think about cinemas and theatres. You just don't want the emergency lighting coming on in test mode in the middle of a feature film. It would just be so inappropriate. After test checking, now, if you've got to do a visual walk around check, it is just not practical in some areas of some buildings. I've already mentioned changing rooms, bathrooms, surgeries, high security areas. You can't just walk into those areas to check that the emergency light fitting is doing what it's supposed to be doing. So that can be difficult in some larger buildings. In a really big building, you've got to locate and rectify the faults. Somebody tells you there's an emergency light fitting not working. Well, yeah, but where is that fitting? Which floor is it on? Which corridor is it? How do you describe its location? What sort of fault is it? You can't expect somebody working away at their desk to give an accurate description of where and what a fault might be. And finally, of course, the record keeping. As buildings get bigger, the record keeping becomes more and more onerous. Whether you're doing it on paper or electronically, it's really very difficult if you've got to maintain it manually. So those are the challenges you've got in medium and large size buildings. And because of those challenges, the responsible person really is at risk of being in breach of the Regulatory Reform Order of 2005.
Sorry, just another question, James.
Yeah, go ahead.
Is an emergency exit sign an emergency light or just an illuminated exit sign and therefore forms no part of the emergency lighting checks as it has no photometric data?
It's still part of the emergency lighting system and it still needs to be tested. But you're correct. It is not a fitting, it's an illuminated exit sign. But if the illuminated exit sign is part of the design of the emergency lighting of that building, then it needs to be tested. And the record of the test needs to be kept. So it's a bit of a hybrid, really. It's not a light fitting because it has no photometric data, but we do still need to know that it's working if it is part of the designed emergency lighting system of the building. Hope that answers the question.
Right, thank you.
Okay, so now we've looked at manual test, we've looked at self-test. What I want to do now is look at addressable test systems. Because the addressable test systems overcome the challenges that I've been talking about. So first of all addressable test systems allow you to schedule the testing so you can make the testing happen at an appropriate time for classrooms and cinemas and restaurants and hospital wards, etc. Secondly, all addressable test systems proactively report faults. You don't have to go there to visually see the fault for yourself. They tell you if there is a fault, and they will also tell you what type of fault it is, the detail of the fitting to which the fault has occurred, and the location of that fault. So addressable test systems will all do that. And finally, addressable test systems all keep their test records for at least 5 years. And 5 years is the legal requirement. You have to keep your test records for 5 years. Addressable test systems do that automatically. So I want to look now at two different types of addressable test systems. I'm going to be looking at Bluetooth wireless systems, and I'm going to be looking at more traditionally wired DALI addressable test systems. And this is going to be very much an overview. This is quite a complex field in its own right. I'll try and keep it short and simple. A Bluetooth wireless addressable system, first of all, one of its great benefits is it doesn't need a load of extra wiring because Bluetooth is used for all the communications. In theory, you can have up to 42,000 separate Bluetooth addresses within a Bluetooth system. Not that anyone would ever need quite that large number, but it's a very large number anyway. And the commissioning of a Bluetooth-based system is all done via an app, either on a phone or on a tablet, and all the reporting would also be done to the mobile phone or to the tablet. So that's Bluetooth. On the DALI side, of course, it's DALI, and I think most of you will be familiar with DALI. Wiring is required. DALI requires a two-wire communication bus. So that bus has to be provided. There is some extra wiring involved, therefore. And there's also a control panel required. So there's a little bit extra dedicated hardware that's required with a DALI wired addressable test system. First of all, let's take a slightly closer look at a Bluetooth wireless addressable test system. Here we go. I'm going to be talking and using as an example a system called HubSense. Now, there are other Bluetooth-based wireless addressable test systems available, but I've got to pick on something as an example, so I'm choosing HubSense. HubSense is provided by a company called Inventronics. By the way, that's not part of NVC, not connected with us at all. Inventronics actually bought HubSense from Osram. So this is all developed by Osram, but it's now owned by Inventronics, which is a big global electronics company, which many of you may well have come across. At the heart of a HubSense emergency lighting testing system, we have, first of all, a qualified Bluetooth mesh. What this means is that we're all familiar with Bluetooth. We're using Bluetooth every day, just about. A Bluetooth mesh is a form of communication between multiple Bluetooth devices. So a message doesn't just go from A to B, it can go from A to B, but it can go via C, D, and Z on the way, if necessary. That's what mesh means. Qualified in this context, what qualified means is this is Bluetooth. This is vanilla Bluetooth. It's not enhanced, added to, padded out by, customized by either NVC or by Inventronics. A qualified Bluetooth mesh is just a pure vanilla Bluetooth. What that means is it's got long-term reliability and compatibility. It hasn't got some special sauce in it that we've added, and if we went away, that would no longer be available. So that's what qualified Bluetooth mesh means. In the system, associated with every light fitting would be the module, the emergency module, which is a DALI emergency module, and connected to that is the qualified Bluetooth mesh to DALI emergency converter. It's a little node. It does the Bluetooth communication, and when it gets a Bluetooth communication, it translates that into DALI language to communicate with the DALI emergency module. And the DALI emergency module does all the things that we've been talking about that emergency modules do, like having batteries inside and switching the relay over from running via the driver to running on battery power, etc. There's the DALI module. So that's got all the BS5266 functionality within it. And at least for commissioning purposes, there'd be a device on the network running the HubSense app. Now, the app is free of charge. You can download it to your phone or your tablet, and you're going to need that for the purposes of commissioning the system. So this is how it would look. So there's an emergency module. The input to the module is DALI. That's how the module communicates. But we're not using DALI for communication to the outside world. That's all being done by the QBM DALI emergency converter. And during commissioning, the emergency converter is connected via Bluetooth to an Android or iOS app running on one of our devices. So there's the app that's necessary for commissioning. In normal running mode, the app does not need to be present. So the app is only there for commissioning purposes. Once commissioning is done, you and your tablet or your phone can be out of the building. You can be on holiday. The system's going to run fine without you. There it is in normal running. And there it is in test mode. So in test mode, according to the parameters that you have set, the system will initiate its own test. So the emergency converter tells the emergency module, start the test. It disconnects the unswitched live supply. That takes the driver out of circuit, brings the batteries into circuit, and there's our LED luminaire now running on battery power, and the indicator goes off saying there's a test in progress. This is familiar territory. This is just the same as with manual and with self-test.
James, I've just got a quick question.
Yes, go ahead.
If installing emergency lighting, is it (brackets the electrician's responsibility to install the exit signage also, i.e. not the lighting, the actual signage which isn't illuminated?
Usually the answer to that would be yes, because it's an electrical device. It's got to be installed by an electrician. It's got to be installed by somebody who's at least Part P qualified, certified. So if the emergency exit sign, well, I'm thinking about this. And the emergency exit sign could be in two forms, couldn't it be? It could be an electrical emergency exit sign, which is illuminated. That's got to be installed by an electrician because it's an electrical device. If the emergency exit sign is just a passive sign, like a sticker on the wall, that would not necessarily have to be installed by an electrician, no. But if it's an illuminated sign, the answer to the question would be yes, it's got to be installed by an electrician. It's an electrical product, and it's part of the fixed installation.
Okay, thank you.
Okay, so what we were looking at there, so that's it during test. The network, the emergency converter has said, do a test. Now what we're looking at is after test. So the unswitched live supply is reconnected. The battery is out of circuit, it's being charged now. The LED driver is back in circuit. And when the device, which has got the HubSense app, next comes within range of the network, it will receive notifications of the tests and the test results which have been completed. So you could be away on holiday in Turkey or in Spain while the tests are going on. You come back from your holiday bearing your mobile phone with the HubSense app on it. You walk into the building. When you walk into the building, your phone will reconnect to the Bluetooth mesh network, and your phone will be filled with notifications telling you these are the tests that have been conducted, these are the results of the tests, and these are the actions that you need to take with respect to any fittings which might have failed the test. So the app connects when it receives notifications when it next connects.
Sorry, James,
So
just going back to that previous question. So I think they were referring to the actual signage, which you did mention the sort of stickers on the walls and things. So is it the electrician's responsibility to install all of the other signage, just the non-electrical signage?
Our audience is asking some really, really great questions today. I'm going to phone a friend on that one.
Yeah, we can come back to you.
I'm gonna check it out, write it down. I'm gonna check on that one and come back to you in writing.
Thank you.
Yeah. Okay, so we've covered everything except from the last one now. So we've looked at the wireless addressable emergency test. Now I'm going to look at DALI wired addressable test. This is the last one. So in normal running, this is what it would look like. So there's our emergency module, same as before. It's connected via DALI, but this time it's connected to the DALI hub. And the DALI hub could be away in the plant room, in a riser cabinet, perhaps away in the basement. And associated with the DALI hub, there will also be a control panel. So there's some dedicated hardware there. But That's the schematic in normal running. Okay, and it's the control panel which is going to hold all the addresses, the test schedules, all of that sort of information, which will have been put there during the commissioning process. The DALI hub supports 128 emergency fittings, but you can expand the DALI hub so it will control multiples of 128 emergency fittings. So you can make such a system as this very large, very extensive. The comms is via 2 wires. It's using DALI. Now, during test, the unswitched live supply will be opened on a command from the control panel. So the control panel just says, yep, it's time to start a test. So open your unswitched live supply. Okay, that means that the unswitched live supply, yeah, it's isolated. The LED driver is taken out of circuit. The batteries are brought into circuit, and the LED indicator switches off to show that there's a test in process. After the test, what will happen? We go back to normal running. The unswitched live supply is reconnected. The charging circuit will be doing its job. And typically, there are various ways of doing this, but typically the control panel would initiate an email to the person responsible to say, these are the fittings which have been tested, these are the locations, and these are the test results. Okay, so that's typically how you would receive your test notifications on a DALI wired addressable system.
Hi, James. Is there an M2 limit when using the wired DALI?
Is there a what limit?
M2.
M2. What is your question asking? Is there a limit to the number of addresses that can be connected? Is that the limit? Is that the question?
Just come back with a follow-up on that, please. Thank you.
I think when he says N2, I think what he's probably
meters
means is
squared.
That, sorry?
Meters squared.
Oh, is there a... No, not really. With the DALI addressable, because everything is wired, there are really no geographical or distance related restrictions in how that works. In fact, a DALI wired system would be the preferred emergency test system very often in on a very large site, like a university campus or a large regional hospital, simply because of the distances that are involved. So the answer to your question is no, there really isn't a physical or geographic limit to how far you can go with a DALI system, particularly if you were to add a gateway and link it via your own IT systems to the wider world. You could have on one system, you could have multiple separate buildings.
Thank you.
So really no limit at all. It's
some other comments about it would be given by the lux level and it's subject to resistance.
I think really I'm not getting the full question there. Lux level is a question of the lighting system design. Lighting, the emergency lighting system should be designed to provide the right light levels in the appropriate parts of a building in the event of a power failure, and there are regulations that cover that. In terms of resistance, yes and no. A DALI network can't exist without a DALI bus power supply. And the function of the DALI bus power supply is to maintain the correct voltage conditions on the DALI network. So long as the DALI network is installed in accordance with the DALI standards, again, there's really no limit to how far you can go with a DALI network, because the DALI bus power supply will keep the voltage at the appropriate level. I hope that's answered the question.
Thank you. I do have another question. How does the DALI or other automatic system know the actual luminaire has illuminated and provided light? Is the visible light monitored in some way? As in manual tests, a person is checking the light output.
Okay, it's not measuring the physical light output. What it's measuring is the current flow that's going to the LEDs. Now, the LEDs are part of the electronic circuitry of the emergency module. So if the LEDs are not working, the electrical characteristics in that circuit would be abnormal. And that would be reported as an LED light source failure by the system. So no, we don't have an optical device, but we can tell if the LEDs are functioning or not by the characteristics of the electrical circuit of which the LEDs are a part. I hope that's answered the question. It's a really, really good question.
Thank you.
It does mean, to elaborate a little bit, that if somebody was so unwise as to, for example, paint the LED panel black so that no light actually got out of it, then the emergency lighting system would not be aware of that, because the LEDs behind the black paint would still be functioning. So your questioner has got a good point there, but such an eventuality, I think, is extremely rare. Right, let's keep moving on then, because we're nearly running up to our time limit that I set for myself.
If any other questions come in, we'll either pick them up at the end or I'll take them to James after the session.
But Kat, there have been some really good questions this session, I've got to say, and that last one really was an excellent one. Okay, so whether we're wireless or whether it's a wired addressable test system, there will still be a monthly check. The status is logged in the system. A notification is automatically sent to the responsible person. The records will be kept for 5 years, and annually the fitting will be checking itself for 3 hours. The status will be logged in the system, notifications, records for 5 years again. So here I usually ask, what are the advantages and disadvantages of addressable test systems compared to self-test? Now, we've covered a lot of the ground already, but what I'm going to do now is just show you a little chart, which I think summarizes in brief the pros and cons of all the different test systems we've been looking at this morning. So down the left-hand side in blue, you see the various parameters we're looking at, the purchase cost, the installation cost, the reliability or system integrity. And across the top, we've got the 4 different techniques we've been looking at: manual test, self-test, wireless addressable test, and DALI wired addressable test. Green generally means good and reliable, and red generally means potentially unreliable or poor value. And what you'll see that as you move from manual test across to the addressable test, we see basically a lot more green appearing in the chart. And in particular, if you look at the left-hand side and you look at the bottom 3 categories, the system integrity in terms of testing, recording, and reporting. This is where the manual test system is really weakest, and this is where the addressable test systems are at their strongest. So if we go right back to the beginning of what I started talking about nearly an hour ago, we were looking at the risks to which the responsible person is exposed, the legal risks of not doing what you should do according to the regulatory reform order. Manual test still leaves the responsible person potentially very, very exposed to BS 5266 not being complied with in full, whereas addressable test systems remove just about all the risk to which the responsible person could be exposed. And that's why, particularly in medium and larger size projects, we really do recommend addressable test systems. And that, Cat, really kind of sums up what I wanted to say. That is the summary. That's where we got to. But
Yeah.
I make it 12 o'clock. We're on the dot. But if there are any questions that people would like to give, I'd be happy to. I'd be happy to take any further questions that there are just now.
Thank you. Yeah, do have another one about self-testing. So going back to self-testing, as an engineer who goes in to do the 3-hour test for the site, do we still have to isolate the power for a 3-hour test, as we don't know when self-testing has been done?
Right. That is a good question. Okay. Do you have to isolate the power? Well, no, you don't, because a self-test emergency module will isolate the power itself. And it will do that 11 times momentarily, just for a few seconds. And after doing that 11 times over 11 months, um, on the 12th occasion, it will isolate the power for a full 3 hours. So no, you as the person doing the checking, you don't need to isolate the power for 3 hours. If you've got a self-test system installed and you're going in there every month to check it, what you're really checking is the indicator lights. Because if the indicator lights are, for example, flashing red, you know that something has gone wrong and needs to be attended to. You don't need to be there checking whether or not it lasted for 3 hours. If one particular fitting didn't last for a full 3 hours, it's the indicator light which is going to tell you that. It's not you hanging around for 3 hours that's going to have to discern that. It's the indicator light will tell you that at some point in the past month, that underwent its 3-hour full discharge test and it failed that test. And that's why the little red light is flashing.
Thank you. Couple more questions. So, what does the DALI controller output have something like a RS232 connection? Does that make sense to you?
Right. Well, okay. I mean, DALI is at one end, DALI connects into, for example, the emergency module or a driver. That's not RS232. It's a DALI connection. It's two conductors plugging in. It's just a 2-wire connection. And the bus is a nominal 16-volt bus. At the other end, the DALI connection again is into the DALI bus power supply and the application controller. And again, that is just 2 wires going into a typically a DIN rail mounted device. It's not an RS232 connection. Connection out to, I mean, the DALI application controller would typically also have a gateway into Ethernet. And then that gives you remote access if you would want to, and that would be an Ethernet connection. I hope I've asked the question. I hope I've answered the question.
Thank you. Does the LED panel not need the LED driver under mains and battery power?
Okay. Let's say we've got a 600 by 600 LED panel. When that is operating under mains, well, anyone who supplies an LED panel, such as NVC or any other lighting company, they will supply that with a driver. It needs a driver. And the driver is always used when the panel is under mains power, because not the only, but one of the main functions of the driver is to convert 230 volts AC to typically 16 or 24 volts DC, which is how the panel operates. So in emergency mode, when the mains power supply fails and the panel is going to be run from battery power, the emergency module takes the driver out of circuit and it supplies the LED panel from the batteries. And in that sense, the emergency module, is actually performing one of the functions of the LED driver, which is to provide that 12 or 16 volt DC power supply. So the power to the LED module, the power to the LED luminaire is coming direct from the batteries. It's 12 or 24 volts DC as it comes from the module to the LEDs in the panel, and the driver's not needed. But if you're running on mains power, you've got to have the driver in circuit because you need the driver to convert mains power down to low voltage DC. I think that answers the question.
Okay, thank you. We'll just do one more question, and then if there are any further questions, I've dropped an email address into the chat, so do feel free to send them. And we can get back to you, and same with the ones that we've said that we're going to contact you afterwards. So is there a requirement to visually check a light is unobstructed and undamaged in addition to the flash or duration test?
Is there a requirement to check that it's undamaged in addition to checking? Well, the duty of the responsible person is to make sure that you've got an emergency lighting system which is fully functional and working and has a system of maintenance in place. And BS 5266 defines the system of maintenance. I would have to go away and check what 5266 says in all of those other pages, in addition to defining that you've got to have the monthly and the annual discharge tests. Kat, I think I'm going to go away and read BS 5266 and see what else it says with regard to any physical defects of the emergency light fittings.
Brilliant. Yep. Okay. Thank you. We can come back to you on that. So I think that's all we have time for. So thank you very much, James, and thank you everyone for your questions. I'm sure everyone's aware that BS 5266 is being updated tomorrow, so do look out for communication from ECA on that and on the changes. And yes, do email if you have any further questions, and I will put this up on the ECA website, the recording of this, later today, so feel free to share it with your colleagues. Yeah, and thank you, James.
Lovely. Kat, thank you very much indeed.
All
Goodbye,
right, thank
everyone.
you, everyone. Goodbye.